So as a result of knowing what the A value, the P value, and the Q value do, you can answer a bunch of questions without your graphing calculator. You can. Like right now, what's the vertex of this? 3 and 1. Excellent. Which way does it open? Does it open up or does it open down? It opens up because the A value is positive. What's the equation of the axis of symmetry? Okay. So let's just quickly sketch this. You just told me that 1, 2, 3, 1, that's our vertex. And we know it's going up. I'm just going to quickly sketch that right now. What is the axis of symmetry? Equals 3. Symmetry is this line that splits it directly in half, and vertical lines are always an x equals equation, because every point on that vertical line has an x coordinate of 3. The intercepts. No x-intercepts. Does it have a y-intercept? How do you find a y-intercept? Plug in x equals 0. That is so important that you think that immediately. Because you know what some people do with this equation? You get so used to the y-intercept being the last number, they just write 1. Always the y-intercept, you find it by plugging x equals 0. If we do that, 1/4 0 minus 3 squared plus 1. I'll have negative times 1/4 is 9/4 plus 1. Add fractions. Common denominator. Can you see that you can make 1 into 4/4? Is 13/4 and not 1. Domain and range. Domain for a parabola is always everything. So our domain is everything. Yeah, we did a quick little sketch there. With that quick little sketch, we found out that it's going up. We know what the vertex is. We could label it. It's 3, 1. Does it have a maximum or a minimum value? Well, because it's going up, it has a minimum value. And our range will be y is bigger than or equal to 1. You could leave it as that, or you could, if you wanted to change it to a decimal, you could. It'll be 3 1/4, which will be 3.25. At the bottom of the page? No, see, it has y is greater, then it has a comma where y is a real number. That's more information, just saying that for all the values bigger than or equal to 1, they're all real numbers that are bigger than or equal to 1. Okay? Now, this form that we just wrote, our domain and range, is called set notation. Sometimes you'll be asked to write it, sometimes in a multiple choice, the domain and range will be written like this in set notation. You also need to recognize domain and range when it's written in interval notation. For all real numbers, interval notation says take the smallest number and then go to the biggest number and write it as an interval. But if you have all numbers, there is no smallest number, so we say negative infinity. And there is no biggest number, so we say infinity. And we write it in brackets like that. For the range, when you want to say y is greater than or equal to 1, in interval notation, use a square bracket when something is equal to. And since 1 is our smallest value, we put the 1 first, and it goes up forever. We'd use infinity with a round bracket. So a square bracket means that the value is included, because we'll get to some equations that just says y is bigger than 1, but not equal. Then you use a round bracket. But when it's equal to, you use a square bracket. We've already sketched the graph if I wanted to plug another point. Because when you sketch a graph, it's not enough just to show the vertex, because you need one other point to indicate how wide or how narrow it is. Maybe you decide to put your y-intercept as your other point and label it. So maybe over here where it crosses, you say, well, I know that when x is 0, I have 13 over 4. And if I label that other point, my graph would now get full marks, because I've labeled a vertex and one other point. Maybe you want to use the over 1, up 1 idea. Since the a value is 1/4, though, you'd have to go over 1, up 1/4. And that would give you, here it would be 2 when I went over 1 that way. 1 plus 1/4 would be 5/4. So that would be another point you could possibly put on your graph to make it work out nicely. However, do you notice both those points are fractions? Sometimes you don't like to have a fraction in there. If I wanted to pick a point that wasn't a fraction, I'm dividing by 4. Can you see that this part, the x minus 3 squared, would have to be a multiple of 4 in order to avoid fractions? So what numbers squared are multiples of 4? 2 squared is 4, right? So how would I get a 2 squared? X would have to be 5. 5 minus 3 would give me 2. 2 squared would be 4. Times by 1/4 would just give me 1. And 1 plus 1 would be 2. That's a nice point. 5, 2. So sometimes you can just look at your equation and find another point with nice values to graph as well, especially if you have graph paper. Oh, and the questions for this one are 6 and 8.